But first, we have to factorise. Looking at this, because we've got a prime number here and a prime number here, we're going to try to do it by inspection. So we believe it's probably 2a and a. And we're going to put 2 in here, and we need to get positive 3. So if I have positive 2 times 2a, that gives me 4a. If I minus 1 here, that gives me minus 1a, which gives me my 3a. So I can go straight on to solving that. So this bracket, a is negative 2, and the solution to this one is 1/2. Second one, we're back to our spotting. It's a difference of 2 squares. If you square root this bit, you get 2a. And if you square root the next bit, you get 3. So it's 2a plus 3, 2a minus 3, giving my solutions as being minus 3 over 2 for this bracket and positive 3 over 2 for this bracket. Try the next one. So in the second column, you can't be sure, is it going to be 6 and 1 or 3 and 2? So you could do it by inspection like the first one, but I'm going to go with a guide method. So if you look at this, 6 times 2 is 12. So I'm looking for the factors of 12 that will give me minus 7. So that would be minus 3 times 4. Gives me 12. So I can rewrite the whole thing, 6a squared. I'm now going to replace this minus 7a with minus 3a minus 4a. Nothing else has changed, and I haven't made it any different. It's still the same thing. So now we're going to just factorize the first part, which would be 3a. 2a take 1. Now we know previously that this will then reappear. And we're now just looking at what do I multiply 2a to get negative 4a? Well, that's minus 2. So at that point, it's all coming together. We've got 3a take 2. And we've got 2a minus 1. Giving my solutions, and I've run out of space. Solution for this one is 2/3. So solution for this one is 1/2. Second one, this is quite a mean one. This isn't a square number, but we can work with that coefficient. So if we square root 2a squared, you get root 2a. Square root 36 is 6, so we've got root 2a plus 6, root 2a minus 6. And then at that point, it's just a case of then solving what we have there. So we've got a equals negative 6 over root 2, or a equals positive 6 over root 2. And we can go back to our working with rationalizing the denominator. This would be minus 6 root 2 over 2. Gives me an answer of minus 3 root 2. And this one would give me 3 root 2. Press pause and have a look at the really fun last two. Okay, working from this one. 8. Well, we could have 2 and 4, 1 and 8. I'm going to go with the guide method to hopefully get there in an algorithmic way. So we've got 40. Oh, that's easy because it says 41. So it's 1 and 40. So I'm going to start off with 8a squared plus 40a plus a plus 5 equals 0. factorize the first section. That should give me 8a plus 5. That's going to be repeated. And what do I times a by to get a? Well, it's just 1, so we've got a plus 1 there. Got 8a plus 1. A plus 5 equals 0. Giving me my solutions of a equals minus 1/8 and minus 5. And I threw this last one in just for fun. So what we're going to do here, well, if we square root 81, we get 9. If you square root a to the 6, you get a cubed. So that's where we're going with a very hidden difference of two squares. So we then got a square root of 144 is 12. And we've got 9a cubed minus 12. Then it's a case of solving that. So you've got a cubed equals negative 12 over 9. Or in the second one, positive 12 over 9. So to get a, you're just going to cube root both of those. It's not something that's going to simplify very nicely. So it's going to be the cube root of negative 12 over 9, or the cube root of 12 over 9. No need to go any further with that one.